Welcome. Let's solve the following inequality. Let's talk about the strategy that we will take. The first thing that we're going to do, we're going to make sure that there is a zero on one side of the inequality. Here's our inequality. So here we have the left-hand side and the right-hand side. But there's an expression on both sides. So let's just move one expression to the other side. The order does not matter. I'm going to move the one on the right to the left. And to do that, let me add the expression to both sides. That way this cancels out. And now let's write our result. We'll get negative 3 divided by x plus 7 plus 4 divided by x plus 8 less than or equal to 0. So we're done with our first step. Now that we have this, let's rewrite the problem just using one rational function, which I'm just going to call it simplify the rationals. Well, one way to do that is to make sure that both rationals have the same denominator. Because after that, we can combine fractions. So let's get our first fraction and let's multiply it times the denominator of the second, which is x plus 8. Let's do that top and bottom. And now let's get our second fraction. And now let's multiply it by the denominator of the first fraction, x plus 7. And now let's just bring down the rest of the problem, less than or equal to 0. So now let's perform the multiplication. Within my first term, let me start by distributing the value of negative 3. Then we're going to get negative 3x minus 24. And now the denominator, I'm not going to distribute. I'm just going to keep them as x plus 7 times x plus 8. Now let's perform the multiplication in our second term. The numerators, notice that there's another distribution. 4 times x, that is 4x. And 4 times 7, that is 28. The denominator, let's keep it as x plus 7 times x plus 8. Let's bring down the rest of the problem. Less than or equal to 0. Now notice that both fractions have the same denominator. Now we can combine numerators. Now we're going to get negative 3x minus 24 plus 4x plus 28 and all over the same denominator, x plus 7 times x plus 8. And bring down the rest of the problem. Now let's combine like terms. Here we can combine these values of x's, negative 3x plus 4x, that is just 1x. And here we can combine negative 24 with positive 28, which is just going to give us positive 4. The denominator, let's keep it as is. Bring down the rest of the problem. And now we have accomplished our second step. We have simplified the rationals. So let me erase some of my work and let's just work with the simplified version that we have just found. So right now we have just shown that what we were given, it can be written as x plus 4 on the numerator and x plus 7 times x plus 8 on the denominator. This is the work that we were just erasing. Now we can move forward to the next step. Let's set the numerator and denominators equal to 0. So let's get the value of x plus 4 and let's set that equals to 0. And let's get the expression of x plus 7 times x plus 8 and also set it equal to 0. And now let's solve each equation individually. On the expression on the numerator, let's take away 4. And now we got a solution that will make the numerator equals to 0. That is negative 4. And for the denominator, let's set each multiple equals to 0. So we're going to get the solution of x equals negative 7 and x equals negative 8. So now we have just found some values which are not the solutions, but we're going to use to find the solutions. Because the next step, it is to use these values and create intervals in the number line. So here we have our number line. And now let's estimate the location of the values that we got here. The value of -8, it is definitely the one that is the most to the left-hand side. Then a little bit more to the right-hand side, this is where we're going to find the value of 7, negative. And more to the right-hand side, we're going to get the value of -4. And notice that when we place those values in the number line, we have created 4 different intervals. The interval from -infinity to -8, let's call that interval number 1. The interval from -8 to -7, let's call that interval 2. The interval from -7 to -4, let's call that interval 3. And the interval from -4 to positive infinity, let's call that interval number 4. And now we're going to be testing values on those intervals. And this is how we're going to find our solutions. So let me erase some of my work to test some of those values. Again, what we did here, we created intervals. So let's test interval number 1. So let's choose some value that is in this interval, some value that is less than -8. I'm going to choose -10. You can choose any value you want as long as it's in this interval. So now let's get that value and plug it in to the rational that we were given. So on the numerator, we're going to get -10 plus 4. And on the denominator, we're going to get -10 plus 7 times -10 plus 8. So now we're going to get -6 divided by +6, which is -1. And now we're going to ask ourselves one question. Is this value that we obtained, is that less than or equal to 0? Well, it is. -1 is definitely less than 0. Because it is true, then any value of x that is in the first interval, it is going to be considered in our solutions. Now let's move to our second interval. Let's choose any number in this interval. Let's choose -7.5. Let's plug that in to our inequality. On the numerator, we're going to get -3.5. And on the denominator, we're going to get -0.25. Well, a negative divided by negative, that is positive. We don't really care what the value is. We just want to know, is the result going to be less than or equal to 0? Well, this is going to be false. So what we are saying is that there's going to be no solutions in this second interval. So now let's test another interval, interval number 3. So let's choose any number in our third interval. I'm going to choose -5. And let's plug that in and see what's the result. On the numerator, we're going to get -1. And on the denominator, we're going to get +6. So now let's ask ourselves one question. Is -1/6 less than or equal to 0? Well, this is true. But because it's true, then any value in this third interval is going to be considered as a solution of the given inequality. Now let's test the last interval. Interval number 4. Let's choose any number that is greater than -4. I want to choose an easy number. I want to choose 0. So let's plug in 0 to our inequality. So on the numerator, we're going to get 4. And on the denominator, we're going to get 56. So now let's ask ourselves one question. Is 4 divided by 56, is that less than 0? Well, this is definitely false. Because it is false, then we're not going to consider any value of x in the fourth interval as part of my solutions. So now let's write down our final result. Our solutions are only in the first and third interval. But the first interval, it is from -infinity to -8. Well, now let's test the endpoint. is it okay for us to use the value of -8? Well, it is not, because if we use it when we plug it in to this second expression, we're going to get 0. That will give us 0 in the denominator. It will make our result undefined. But because we cannot use it, then we have to represent this as a circle with a hole on it, and therefore we have to use a curved bracket in our interval. Now let's use the symbol of union, and now let's write the third interval, which is from -7 to -4. Well, now let's test some endpoints. The value of -7, is it okay to use it? Well, it is not, because notice that if we plug that in, we are going to get 0 in the denominator. That's going to make it undefined. We cannot use the value of -7. We have to represent that with a curved bracket. So let's represent that with a circle with a hole on it in our number line. So now let's test the last endpoint, -4. Is it okay to use -4? Well, when we plug it in, so essentially we're going to get 0 divided by whatever value we obtain on the denominator. We don't care, because this is going to be equivalent to 0 regardless. Well, is 0 less than or equal to 0? Well, it is true, because this time we are using the equal sign. We should include it in our solution. So we need to represent that using square bracket. And in terms of the number line, we can represent that with a whole circle. So we are done. Choose any value that is in my first and third interval that is going to be considered a solution of the rational inequality that we were given.
Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.